Okay. Hello everyone. I'm Vicente, and now I want to solve a challenge in order to application for the machine learning engineer position. Okay. So first of all, I'm going to, well, in this case, I have the data set, and I'm going to code all the project in that script. So what I am going to do? Well, I'm going to follow that steps. For instance, first of all, I want to perform feature engineering. I mean, I want to evaluate the correlation between features, and I want to delete some features if it is necessary. After that, I'm going to perform machine learning models in order to train all the data set. And finally, I'm going to apply hyperparameters optimization. In that case, I'm going to use grid search. For example, in that case, in the second, well, in the second step, I'm going to use supervector machines, random forest, add a boost, nearest neighbor, and what else? Knife values. Yeah, that's all. I'm going to evaluate that models. Then I'm going to when I got the best model, I'm going to use grid search in order to fine tune that model. Finally, I'm going to build function for inference, for making inference, according to the requirements for that challenge. And finally, I'm going to explain how to use natural language processing or description. Which, yeah, that's all. That's all the activities I'm going to do. We are going to start. Okay, so first of all, I'm going to import the package I need. For instance, I need NumPy. I also need pandas. Yeah. I'm going to use sklearn in order to apply all the machine learning models. So from sklearn dot model selection. Okay. In this case, yeah. My selection, I'm going to use train test split in order to split the dataset, and also I'm going to use grid search for hyperparameters tuning. Then I'm going to use also, I'm going to copy that, scan out. I'm going to use from preprocessing. I'm going to use one hot encoder, then a standard scatter in order to scale all the features. We can use standard scatter or maybe min-max scatter. And also we can use label encoder. Maybe we have some categorical features, so we need to encode that. What else? So we need also some metrics, like for instance, well, I prefer to use accuracy, and also F1 score. I prefer F1 score because it's evaluate in a appropriate way a model. Then I want to use from sklearn. I want to use supervector machine. Then I want to use from some package. I want to use London Forest. Then add a boost. Also, I want to use from the knife bias package I'm going to use the Gaussian. Yeah, also I need from the all neighbors from the model of nearest neighbor. I want to use that nearest neighbor. I want to import the nearest centroid. Yeah, that's all. I think I have all the models: random forest, Adabus, supervised machine, nice valles, and nearest neighbor. Yeah. Now, so I need to save the model, so I'm going to use joblib. Okay, and also I'm going to save the scalar. So in that case, joblib is for saving the is a package in order to save the scalar, min max scalar or the standard scalar, and pickle is a package in order to save the model. Yeah. Also, I would like to plot some data. So I want to use import matplotlib. Matplotlib. I know space py plot as plt. Also, maybe we can use cabol. Okay. And finally, it has some statistical features. I'm going to use stats in order to import the chi-square contingency. Yeah, I think it's okay. See about stats, import as from CPy stats, import chi contingents. This package is very useful in order to evaluate the correlation between categorical features. In order to avoid warnings message, I'm going to use that warning filter warning. No, yeah, I think in that case I have a mistake. Yeah, that's all. Okay, that's all. That's all the package I need. I want to need. I want to land it. Oh, I have some filter warnings. I think it's yeah, excellent. So we're going to start using the feature engineering. In that case, I'm going to evaluate the data set. I'm going to open the data set, evaluate each feature. I'm going to evaluate the correlation between attributes. So we need to research about what features are relevant and what are not. Okay, so first of all, I'm going to open the data set. So with the data set is trained. Excellent. Now, for instance, I'm going to see the data set. Okay, yeah. We have a lot of features, as we know. For instance, the UID, it's not important, and also the description. What else? Wait, for example, we have the CD, and the home time, stream features. Maybe they can be converted to categorical features. Then there was out numerical features. And finally, the price range is the target. In that case, the price range is a range. So yeah, we need to analyze if that problem is a regression or a classification problem. Okay. So first of all, I'm going to drop some features like I said before, the UID. So this is in the axis 1 and in place. True. So this is I'm going to delete that column in this data frame. I'm going to do the same for the description field. Okay, description. The description. Okay. Yeah, after that, I would like to know how are these features, CD description. Yeah, first of all, we're going to delete that. Yeah, excellent. I'm going to see the well, what features I have. CD home time, CD home time all of type object, then has spice and boolean, and that's all. All the rest are numerical values. So now I'm going to evaluate home time, CD, and the price range. Yeah, I need to see how many categories they have. So we're going to print the data set, CD, okay, point to unique in order to see the unique values. I'm going to do it for all the categorical attributes or object attributes. Yeah, home type has spa. The price range. Okay, so yeah, we had some categories for that feature. For instance, CD, we have Austin, Del Valle, Manchaca. For home time, we have single family, multiple occupancy, condo. For hot spice, it's Boolean, so false true, all the values. And the price range, in that case, we had that. So in that case, we see that the price range is it's not a regression problem. It's no, well, that problem is, that data set is not a regression problem, it's a classification problem because we had just five classes from 0 to 2005, 25, to 25 to 35, 35 to 45, 45 to 65, and 65 to more. Okay. So I would like to count that values in order to see the relevance of that features. For instance, I'm going to count that values. Data set. I'm going to start with CD. Yeah, and value counts is the method. For example, yeah. For example, CD. For the CD feature, we have a very unbalanced data set. For instance, it's unbalanced. We see here that for Austin CD, we had 9,000 samples approximately, and the rest are not relevant. Interesting. I'm going to validate the rest, for example, home time, then pass spa, and price range. I don't know how is that. See it. For example, home time. Home type, it's also unbalanced. We see that for single family, we have 9,000 features, and the other categories have a very small quantity. For the spa, yeah, it's okay. There's no problem. And the price range. This is the target. So yeah, it's a balanced data set. So we can see that the CD and the home time. Yeah, that case, yeah. the CD, and the home type. All features very unbalanced, so maybe we can drop them in order to avoid some problems when training a model. So I'm going to drop them. Here we have, I'm going to copy that instruction. Yeah, we're going to select the city and the home type. Home type, okay. Okay, so what else I need? Maybe we are going to see the dataset df.set. Yeah, we have only the latitude, longitude, all the numerical features. And also we have the price range. Okay, so this is a string, so we need to convert it to numerical values. Yeah, I'm going to add some kind of a string in order for documentation. So relation of balance features in that case. Then I'm going to, in that case, I count, no? In that case, I count categorical features. Yeah, that's all. Yeah, so now I'm going to convert that price range to numerical values. Okay, I'm going to here and convert values to numerical classes, for example. Yeah. That I'm going to delete that. Yeah. Okay. So I need to replace, no? For example, instead of 0 to 25, I'm going to use a number like 0. Then instead of 35 and 45, I'm going to use another number, maybe 2 or 3. Yeah, here I have all the values. So I'm going to copy that. Okay, I'm going to use here, like a comment. So, yeah, I'm going to do it. I'm going to use a price range liquid. I need to use a dictionary. Okay, so for 0 to 25, I'm going to use a 0 class. From 25 to 35, I'm going to use the 1 class. Then 35 to 45, it will be class 2. 45 to 65 will be class 3. Then more than 65 will be the class 4. Yeah, I had a dictionary, so now I'm going to use that in the dataset. In the column price range, I'm going to replace that dataset. Price range, control replace, and I'm going to use this dictionary. Yeah, I know. Okay. Also, yeah, maybe I can see the data set. 8. Yeah, I had all the futures. I had a price range with numerical values. Yeah, it's okay. Now, I would like to know what are the categorical values and the numerical values in order to analyze the correlation between them. So I'm going to use the cat calls, which will be a list with all categorical values. CD, for example. What else? Home type, I think. And has a spa, if I remember. Yeah, has a spa. See the home type, yeah, that features well deleted. Then from numerical calls, we have all the rest. It will be the latitude, also the longitude, garage spaces, years built, none of Patreon Pulse features, lot size squared. I'm going to move that here. Yeah. Then log the average school rating. Okay. And the median students per teacher. There is a lot of features. None of battalions. The none of battalions. Yeah, that's all. That's all the numerical features. So, yeah, I have deleted the city, the home time. Yeah, that's all. I think that I don't need more. I'm going to run this code. So I'm going to use a heat map in order to know the correlation between that numerical features. So I'm going to put here, I'm going to use it like heat map for correlation analysis. Okay. Yeah, so now the code. Excuse me, the code. It's not here. Yeah, okay. So I'm going to use a heat map. So I'm going to create a new data frame from the columns with numerical values. So it's in that case data set and non-calls. Yeah. And just here we have a new data frame containing only numerical attributes or features. Then I'm going to create a correlation object. Is from the correlation data frame. Here we have a method named call. So I'm going to use the Pearson method. Okay. Now I'm going to plot that. I'm going to use matplotlib. Use a figure of size, fixed size equals to could be 10 to 8. So I'm going to use Yabo in order to plot a heat map. I'm going to use the correlation. I'm going to use the annotation. I'm going to use the annotation values. The color could be colon 1. Yep. That's all. Maybe we can use title. We're going to name it correlation. Okay. Finally, put it plt.show. Oh, here we have some errors. It's not called that way. Oh, cool is cool. Column one is with M. Yeah, here we have a heat map. It's important to know that we can use that method, the Pearson method with heat map, in order to know the correlation between features, but only we need to consider only the numerical features. For that reason, we divide that columns, numerical features and categorical features. In that case, for example, we need to find for let values, ignoring the diagonal, and that's not the case in this data. So we see that there is no features that are correlated, very correlated, no? So just the median student per teacher that is correlated with the average school rating, but it is small in my opinion. So we don't need to remove them. If we have two attributes that correlates highly, we will need to remove one of them. In that case, it's not necessary. Yeah. Now I'm going to perform correlation analysis over categorical features. I'm going to here correlation analysis over numerical features. So in this case, I only have the HasSpa feature because I deleted city and home type. Okay, so I'm going to use it. The method is the chi-squad. Chi-squad. I'm going to use it over the first tab. I'm going to use here the data set over the price range against data set against the HasSpa. Spa. Okay, yeah, it's got stop. And yeah, I think that it's okay. So I'm going to print it. Print this Q. Okay, oh, yeah, I'm going to, this is the p-value. Yeah, let's see it. Okay, I see that there is a small p-value. Okay, so we don't need to delete that. It's very small. In that case, what I want is that, yeah, this is the correct p-value. It's 1.4 with a lot of decimals. So it's very small. So we need to use that feature. Maybe we also can plot a histogram in order to see the correlation. For example, I'm going to use it. Yeah, maybe we can use subplots, fixed size. Okay, subplots. It's okay, fixed size. Let's do that size. Now we're going to use Seable. The name is complot. Okay, then the x-axis will be the price range. The data will be the data set. And the hue will be the FastSPA. Yeah, it's okay. Complete, press launch. Yeah, it's all okay. Let's see. Let's set a limit in the y-axis, 0 to 500. Yeah, that's what I'm going to show. Let's see it. Yeah, for example, in that case, we see that the price range is kind of correlated, no, with HASSPA. With more HASSPA, it's more probably to have a price range of class 4 that is the more expensive price, no, or the most expensive house. Yeah, it's okay to use that feature. Now we're going to look for new values. So in that case, it's very easy because we just need to the data set dot is null. It's null. Soon I'm going to zoom that. Yeah. Okay. So I'm going to zoom the null values for each feature. Yeah, I don't have null values, so it's okay. Yeah, I almost finished. What can I set before starting with the machine learning model? We deleted the two categorical features, city and home type, because they are very unbalanced. And we perform a heat map analysis in order to know the correlation between features, and we found that there are no correlated attributes. Also, we perform the chi-square method in order to see the correlation between categorical features. And in my case, the only categorical feature I have is HASPA, and it's not necessary to delete that. So now we can start using a model, machine learning. Okay, so I'm going to define the data set for the training samples. For example, in that case, I'm going to use the data set. I'm going to drop the target. So price range. Yeah, price range. Okay. So here we have the X data, that all the future without the target. And the Y data will be the same. No, it's not the same, it's data set. And I get the price range. So now we have all the data set. I'm going to print the shape of each matrix. Let's see it. Yeah, we have 10,000 samples, and we are evaluating 11 features. Yeah, that's okay until now. What else? As for example, if I print the features, I see that yeah, we have a lot of numerical features. However, we have very large values. For instance, the yield, the latitude, longitude, the lot size square foot, the average school rating. So it's very complicated to use that features or that values for a machine learning model. So I'm going to use a scalar in order to get features more simple or with smaller values. Okay, so I'm going to put a code here. Okay, so yeah, I'm going to use a scalar. we can use the min max scaler. I import that package before. Scaler.fit, it's a method very similar to a machine learning model. I put here until that case, until this step, I fit the scalar. So I'm going to put here scaling features. Then I can transform or scale all the features. For example, scalar.transform. So now I want to scale all the features in the dataset. Yeah, and what else also I need? I need to, yeah, I have all the data here in that matrix. But in order to relate our models, we need to divide this data set in order to have a training set and a testing set. So I'm going to use a method, is the train test split, that returns in this way. Train, test. Okay, so the method is train test split. I want to indicate the X and Y data. The Y data I'm going to see it. Yeah, it's okay. Okay, Y, X and Y. And yeah, it's a scale. Well, I want to use the test site. Okay. I'm going to use 20% for the testing set. It's very useful to use a random state. It's like a seed in order to, for example, we are going to run this command several times. I need to get the same results. So for that reason, I use a seed. It could be what any number. So it's just for replicate or duplicate the results. Yeah, that's all. I think. Okay. For instance, I can print the strength, the size. Yeah, I have 8,000 samples for training and 2,000 samples for testing. Yeah, okay. And train test split in order to be more yeah, that's all. So now I'm going to evaluate the models. Yeah, as I said at the beginning, I'm going to evaluate several models like random forest, AdaBoost, Gaussian, nearest neighbor, the nearest centroid, and supervector machine. So, okay, here we have evaluating machine learning models. Okay. So here we have, I'm going to, each time I evaluate and train each model, I like to recall the metrics. So I'm going to use a data frame that will store all of that metrics. For instance, I'm going to create a results. This is a data frame. The columns will be the accuracy and the F1 scope. These are the metrics I'm going to use, and the index will be all the models I'm going to use. For example, random forest, AdaBoost, Naive Bayes. What else? Nearest neighbor, and finally supervector machine. Yeah. So in that data frame, I'm going to store all the metrics. Yeah, also, as I want to do that several times, I want to create a function that will name store metrics. I always use that kind of functions in order to analyze the metrics of several experiments. Here we are going to have the prediction of each model and then the model name. Yeah. So I'm going to evaluate the accuracy. The accuracy from accuracy score is a method that I import at the beginning from JPRED and JTest. I have the JTest here. And JPRED will be the predictions of each model. I also am going to calculate the F1 score from F1 score. In that case, I'm going to use average weighted. Yeah. I'm going to start in the results. So I set in the model name also. I'm going to put it model name in order to be more clarify that. The accuracy. The accuracy, I'm going to stop the accuracy. So what happens here? Model name F1. Here. Yeah. So with that function, I'm going to store all the metrics I'm going to have with all experiments. So I'm going to run this. Yeah. So now to evaluate. Yeah. I'm going to start with London Forest. So London Forest. Okay, so I'm going to put this model equals to London Forest classifier. I'm going to use the max depth equal to 20, for instance, and London states 0. It's not relevant, that number. Then the model punto fit. In that case, I'm going to train that. I'm going to use the strain and the train. Yeah, I'm going to train it. Then I'm going to calculate the predictions. The model punto predict. I'm going to give the X test. Yeah. In that case, I define the model, I train the model, and here I got the predictions. And finally, I'm going to store the metrics. I'm going to give the prediction. Then the model name is London Forest. Okay, I'm going to evaluate that. I'm going to print the results. Okay, yeah. For instance, for London Forest, I have that accuracy and F1 score. I'm going to do the same for all the models. For instance, I'm going to do the same for supervector machine, which it's almost the same. So in that case, I'm going to use another model here. It will be supervector machine dot SPC. Yep, it's the same supervector machine. Vector machine, X train, Y train, X text. I'm going to print the results. Okay. Yeah, I have also supervector machine. Excellent. Now I'm going to do it for what else? AdaBoost. Okay, for AdaBoost, then the model, the package is AdaBoost classifier. Here we have some parameters like the estimators. I don't know, you can use 100. The algorithm will be the same. The random state 0. Yeah, AdaBoost. Also, I want to use AdaBoost Naive Bayes. Naive Bayes. In that case, for Naive Bayes, the name is I don't remember. The name is, I think, that Gaussian NB. Gaussian NB. Gaussian NB. And then I'm going to use the naive Bayes. Finally, the nearest neighbor. Okay, in that case, is the nearest centroid. Nearest centroid, yeah. Yeah, it's okay. Nearest neighbor, naive Bayes. Okay, the name is that. I think that I finish. I'm going to see the results. I had a problem. The boosting. It's in the algorithm parameters. The boost must be as the same. I have error here. Okay, I'm training all the models. Yeah, I have the results. For example, here I have the results. I am using the accuracy and F1 score. I prefer to use the F1 score because it evaluates better a model in order it joins the precision of the code metrics. So it's a much better metrics than accuracy or precision or score. Moreover, according to our results, we see that random forest is the best model. It's not excellent. However, I consider that we have acceptable results. Maybe we can apply hyperparameter tuning in order to improve that results for random forest. So we are going to do it. We are going to apply a grid search. It's a method to use the basic parameters for a machine learning model. So I want to create a new model. I want to use random forest classifier. This will be the model. Random state equal to 0. Now I'm going to create the parent, or all the parents, all the possible parents for the grid search algorithm. Yeah, for example, we have the estimators. I think the estimators. I'm going to evaluate from 200 to 500. Also, I have the max features in the random forest model. Features, it will be from auto SQLT. Also, the max depth, it's very important in random forest, max depth. I'm going to evaluate with the depth of 5, 10, 15, and 20. And the criterion, yeah, I'm going to evaluate the Gini. Yeah, I think that it's enough. So with grid search, I'm going to evaluate all possible combinations between that hyperparameters. So that method, I'm going to return the best hyperparameter for random forest. Yeah, okay, so I'm going to save that the model in grid search. I'm going to use the estimator. It will be, well, the model first of all. Then the parent grid will be that parent grid. So I give the model and all the parameters possibilities. Now, C1, I want to fit that. It's very similar the training of a model. Train. Then I'm going to train that. Then I'm going to print that. The basic parameters that are in the best parents, I think. Best parents. Yeah. Yeah, that's okay. That's okay. So I'm going to stop that because mejor it's better that I'm going to bring it then. Okay. So we are going to wait for that for in order to finish the learning of this code. So in this case, the sklearn package is using the grid search method in order to find the basic parameter combination. It's very useful. It's very useful to use that for small models like random forests, supervector machines, or very small data sets like this challenge. So as the method is looking for several combinations, it could take some minutes. So we're going to wait for that. Maybe we can do we can explain a little bit more about what we are going to do. So we start importing all the package we need from Python, sklearn. Also, we are using some package in order to plot the correlation between features. In that case, we open the data sets, we drop features that are not very useful, like the UID and the description. In that case, we analyze the categorical features for like CD, home type, HASSPA, and the price range, and we count that all the values for that features in order to know that if that features are balanced. So we notice that CD and home type are unbalanced features. So in the following section, we will remove that CD and home type. Then we get just 11 features. Moreover, we have another problem with the price range because it's a categorical feature. So it's a string. So in that case, in this case, we convert that categorical feature to numerical values. For instance, from 0 to 25, we use 0. From 25 to 35, we use 1, and so on. Then we replace that column. So in here, we have the 11 features and also the target. Yeah. The only categorical feature is the HASSPA. The rest are numerical features. So in that case here, I divide the categorical features and the numerical features in order to analyze them in a more appropriate way. In here, I use a heap map in order to know the correlation between features. So we know that there is no correlated features. We also use the chi-square method in order to see the correlation between categorical features and there's no correlated features. Then we use the machine learning models. We evaluate all of them. I'm going to use grid shells, and here we finish the grid search method. So we have the basic parameters. So we are going to train a new model using the best parameters. So I'm going to use the random forest that I use here. Okay, however, the max depth is 15. The max features, I'm going to use all of that. I'm going to use criterion. Equal to entropy. Then max features equal to square t. The estimators equals to 500. Yeah, the max day, estimate max dev, criterion, it's a lot. It's okay. We're going to train on one more time. We're going to we don't need to store that metrics. We're going to just do it. I'm going to print. Well, I'm going to print the result. So I'm going to use it. Yeah, maybe I can't. Yeah, I'm going to just print it. So here, okay, yeah. I'm going to get the accuracy, the F1 score. Then I'm going to print the accuracy and then the F1 score. The accuracy. Yeah. So the model, we create a model with basic parameters, we train it, we predict, and we calculate, we get the accuracy and the F1 score. So we're going to wait it. Yeah, we have, yeah, here we have a accuracy of 63% and F1 score of 62, which are better than the other model. So yeah, it's okay. We increase the performance of the random forest model. So we're going to save that model. Yeah, so now we are going to save the model. In order to save the model, it's easy. Yes, open. I'm going to name it model.pkl. Now I'm going to use pcode dot down. The model is here, this variable. Okay, and that's all. With that, I'm going to save the model. Also, I'm going to save the scalar because it's very important to use it for making predictions. So the scalar is scalar. Yeah, so here I'm going to use scalar. The scalar is, I'm going to save it with joblib. Dot down. And the scalar, the name will be scalar. Yeah. Yeah. Now I will have the model and the scalar. So it's the all necessary data in order to make predictions in the future. So I'm going to put here another section for making inferences. Yeah, I'm going to, first of all, I'm going to open the model and the scalar. Yeah, so in order to open that, first of all, I'm going to decide we need some examples of testing data. So we are going to define that. Yeah, so I'm going to set, maybe I'm going to open the data set. I'm going to find where is the data set stop. Give me some minutes. And the data set is here. Challenge. Yeah, this is the data set. Yeah, here we have some samples. Okay, so we need the latitude, longitude. We're going to take that, and then I'm going to change some values in order to make predictions. Yeah, so I'm going to stop here. These are some values. Yeah, I'm going to define them. Yeah, we're going to start. So I'm going to open the model. So model, the name is PKL. Now the model will be named that. We call punto load. Yeah, I'm going to open the model. Now I'm going to open the Scala. Yo click, load, the name is Scala.safe. Yeah. So first of all, I'm going to open I'm going to put here, open the model and Scala. Okay. Yeah, the model is CLF and the scalar is Scala. Now I'm going to use the data. So I'm going to create a new input. I'm going to name this new. So it will be a NumPy array. Okay. So here. Yeah, I'm going to put it here. We have the latitude. This is a sample. Latitude, longitude, separated by comma. Is going to be false. Yes. We need to have 11 features. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, we have 11 features. I'm going to have another feature. For example, it could be, maybe I want to put here 1, I'm going to put here 2. Yeah, okay. Yeah, we had 2 samples. We are going to make predictions for these samples. And then I'm going to scale that data. So I'm going to use the scale. Scalar.transform. Okay, so these are my my data. I'm going to scale that. And finally, I'm going to make a function for prediction. So I'm going to create a function named inference. Inference needs x. I'm going to make the predictions. It's easy. Just call the predict method. The method need to be scaled. We also use that. And then I need to return that, return the predictions. Okay. So I'm going to print here. Here we have the function we were asking in order to make predictions. We are loading the model and the scalar. So here, inference, I'm going to give the x. Okay, so I'm going to test it. Yeah. For example, we have for these 2 samples, we have the class 4. Yeah, for instance, if we need to know the real value, if we remember the target values were that values are not a class. So we're going to create a function for mapping. It's easy. I'm going to use map. Yeah, I'm going to use this dictionary. Okay, so however, it's different because I'm going to use for 0. I want that for 1. I want that for class 2, for class 3, for class 4. Okay. Yeah, that's all. I'm going to put that. I'm going to go through the branch length of out. So now here before the tuning, I'm going to tune a list map. I'm going to map. I'm going to give the function mat out the prediction. That so in here I'm going to map all that. So each element are going to be converted according to the dictionary. Yeah, so here you have the prediction for this sample. We have two samples, and the prediction are that this is the column, the price predicted for this data. Yeah, we finished. We finished. So finally, we need to explain how we can use the description. We deleted this feature, the description. Here we have Excel with the description values. So yeah, what we can do for that, no, for the description method, for the description feature. It's very interesting how complicated, how complex as this data. For example, if we analyze the data, we see that there is a lot of information. For example, we can see here that we have a size, which is different to the size column here. So maybe if we see here that we know that we see a pattern in order to store the size. So in my opinion, the first step is to use a regular expression over each sample in order to extract that information, this size. Yeah, this is maybe I can apply it in a very easy way. Then what else we can do? For example, we see here that we have a lot of information. So I want to test ChatGPT in order to know if we can extract relevant information. For example, extract one types from. I'm going to evaluate it using ChatGPT. For example, here we have that. For example, for the description, for the normal description, we can get information about additional rooms like the living room, dining area, kitchen, bathroom, laundry room, utility room. So what I can do, what will I do? As we are seeing, using the description field of each sample, we can extract additional information like the type of rooms that a house has. So we have two options. We can use, I'm going to write it in order to be more, to explain it better. Yeah. So the first step will be use regular expressions to get the size. It's very easy, in my opinion. Then use a large language model in order to extract additional information like the type of loans. It's an example. For instance, here we can use, we have two options in order to use a large language model. Use ChatGPT, for example, API. If ChatGPT have an API, we can use it to get the information. And the option I will use, will be use geometry. It is open source language model. For example, we can use it from Hugging Face. Hugging Face is it's a web page that have a lot of language built and transformed model. For example, here we can find for geometry, and here we have the geometry model. So we need to fill a form in order to have the permissions to download it. So here we have the whole model, the whole parameters, and we could use it to use like ChatGPT. So we don't need to have an API. We don't need to pay for ChatGPT. We just need to download it. Also, we need a computer that can support the amount of data for that model, the amount of parameters. Yeah, and yeah, that's all. Then with that additional information, we can include, we can add more features that can improve the performance of the model. Yeah, that's all. So finally, increase the number of features according to the output of the large language model. Yeah, so that's the way I will use natural language processing over this data set. Yeah, that's all. Thank you very much for your attention. Bye bye.